from the kind of knowledge which does not give benefit, from the heart in which there is no fear, from the soul which does not become satisfied, and dua which is not accepted. O Allah, nothing is easy except what you have made easy. If you wish, you can make the difficult easy. O Allah, benefit us with what you have taught us, and teach us that which will benefit us, and give us knowledge that will benefit us. Now, we move on to the supplication that our Prophet, peace be upon him, always used to supplicate. O Allah, we seek refuge in you from incapacity, laziness, cowardice, old age, miserliness, and disease. Our Lord, give us goodness in this world and good in the hereafter, and save us from the torment of the fire. وصلى الله على سيدنا محمد وعلى آله وأصحابه وسلم تسليما كثيرا.
اللهم صل وسلم وبارك على سيدنا محمد.
Ameen, Ameen, Ya Rabbil Alameen. Thank you, Uniten student, for joining this workshop. Ladies and gentlemen, my name is Leila Himer, and I'm your MC for today. The speaker will demonstrate and illustrate this program. Every session will conclude with a simple task to test your comprehension of how to utilize this program. Ladies and gentlemen, we are pleased to introduce to you our speaker for today workshop, Dr. Muhammad Noor Al-Alam. Dr. Muhammad Noor Al-Alam has completed his PhD at Uniten University, and currently he is research director at Institute of Research and Skills Development. And without further ado, I would like to invite Dr. Muhammad to start the workshop. Dr. Muhammad, the stage is yours. Thank you.
Thank you very much, dear sister Laila, brother Tariq, and brother Hudayfa for organizing this, and for a nice introduction and for supplication. Thank you very much, all of you. We can start now, no problem, inshallah. Are you ready, inshallah? How are you? Everybody fine?
Fine, Doctor. Thank you so much. You are welcome.
Okay, inshallah. Everybody got my assignment and data set and questionnaire that I delivered to Sister Laila. Maybe she has distributed these materials among you. Is it?
Yes, Doctor already shared the material with them.
Okay, okay. If you go through that materials, you will observe how we collect data through the survey questionnaire, what are the different variables and related indicators that we used for measuring different variables, and how do we collect data, and how when we put the data into the SPSS software, how it look like. If you go through the second file, that is the SPSS file I have given you, and another file I have given you, that is the assignment questions. So hopefully you will be able to do it, and that would be your even after today, yesterday and today's session, maybe you will be able to do all the tasks given to you. So we can start for today's session, inshallah. And I am sharing the screen. I am audible. Everything is fine.
Yes, sir. Loud and
Hopefully you are watching my screen, right? Everybody?
Yes, sir. You can proceed.
Yes.
Okay.
Yes, Doctor.
Yesterday.
Yes, Doctor.
Okay. Last day we did our work until
Doctor, please.
Yes, please proceed, brother. What you are saying?
Doctor, please.
Please, brother. Yeah. Please carry on. What you are trying to say?
Could you
Please
make,
tell me,
could you
brother.
make, doctor, could you make a quick revision for yesterday lecture?
Yes, yes, yes. That's a very nice
Okay, doctor. Okay.
Request that I must do. Last day, I have given you some introductory talk about the statistics and what are different kinds of variables that we measure. And you know, these are the basic concepts and in basic statistics and basic terminologies that we use in SPSS. Besides of these, we have some other as well. So this is not limited with this. The variables is the construct or the factors which is based on the concept and which do not measure by itself, which is been measured by the indicators, that is called the variables. But however, there are two kinds of variable. One is a latent variable, another is observed variable. Sometimes the items, the statements and the questions or the indicators, these items or indicators, sometimes we denoted it by the observed variables, and the construct and the factors like independent variable, dependent variable, mediating variable, moderating variable. These kinds of variables we say it is latent variable. So observed variable are the items or the indicators, and latent variables is the concept or the construct, and it is or factors or determinants. So population, you know, the population is from where we collect the data and where we want to generalize our study. That is called the population, an aggregate of all individuals or objects defined on some characteristic, that is called the population. And a sampling unit means our respondents. Who are our respondents? The individual or the object which may be a sample. They are called sampling unit. The sample is a representative, a small part of population. An experiment, an act which has two or more results or output, that is called the experiment. A random experiment, an experiment which is done many times, that is called the random experiment. Then measurement, a process of assigning numbers to a variable value. Then statistics, the characteristics of samples, sample mean, sample standard deviation, sample variance, etc. is called the statistics. Then what is the parameter? Parameter, a characteristic of a population, population mean, population variance. So it is called the parameter. And the frequency distribution, a set of classes together with frequency value in every class of a data set. What is mean? A representative average of a sample, arithmetic average. And what is mediation? The most middle observation of an arranged data set in a data set, which is the middle value, that is called the mediation. What is more? The value of observation in a frequency distribution which is maximum in number. Okay, that is called or highest value, that is called the mode. These are the basic concepts, and we have some descriptive statistics. In the descriptive statistics, we have measure of central tendency, mean, median, mode, that we can find through the statistical analysis by using SPSS. Then measure of dispersion, variance, range, standard deviation. Then measures of skewness, measures of kurtosis. When your data set is somehow it is skewed or it is kurtoed towards left or right, that we can measure through the skewness and the kurtosis. To observe the data normality. The data, if the data is normal, it should be bell-shaped. If we go for the graphical representation of our data, then it will come, the normal shape will be bell-shaped. Then inferential statistics, it is two types: estimation or estimates. The beta value, it represents the estimation, and it comes through the inferential statistics. And test of hypothesis. In the hypothesis, actually in social sciences, our quantitative study is based on the hypothesis, cause and effect relationship. We hypothesized based on the theory. We hypothesized something, and after collecting the numerical data, the survey data, after analysis, we get the results. We test our proposed hypothesis is significant or not. So that is the study that we do in our through the statistical technique like SPSS. So our quantitative data that that data can be analyzed through this statistical analysis. The qualitative data we cannot analyze by statistics. For qualitative data, you can use some other software like NVivo or Stata or GMM. You can use different other or Atlas TI. So for qualitative data, we have different other softwares. For quantitative data, the basic tool is the SPSS, and we have some advanced tool like SEM, structural equation modeling, AMOS, and Smart PLS. I also teach this software. So if you look at the your groups, you will find different banners are being I sometimes share for the students. So and types of different variables that we talked, and you know the we have two kinds of data. One is parametric data and another is non-parametric data. Parametric data, we say if your data set is normally distributed, that is called parametric, and data is not normally distributed, then we say non-parametric. If your data is non-parametric, you have a different set of tests, and if your data is parametric, then you have the different sets of tests. So we have different kinds of scales: nominal, ordinal, and interval. Nominal, suppose gender, job category, country, department. Where we don't use any range, that is called the nominal scale. And the ordinal is when we use any range, suppose low, moderate, high, then it is called ordinal. And interval, which is continuous in nature, that is called the interval or the ratio. So last day we learned how to give input in SPSS software. We have given example that is two kinds of information we have normally we have in survey technique. One is demographic information, another is Likert scale data. In demographic information, we have sometimes this type of demographic information: department, designation, gender, marital status, like this. And we have the Likert scale data like ways. This is one variable. This is called the latent variable. And these are the, suppose these are the statement. This is called the indicators or the items or the questions. So these are also called as observed variables, which has been measured, that is called observed variable, and which cannot be directly measured, that is called the latent variable. So if you open the SPSS software, you will find two view. One is data view, another is variable view. Brother, please check someone's someone's There it is, their mic not mute. So please everybody check your mic is mute. The noise is coming. Okay. Okay. Okay, everybody check your mic is mute. Okay. So in our variable view, we put the feature of the data, and based on that in data we put the numeric values of the respondent data based on the feature or the criteria that we put into the variable view. And last day we practically have done it, and today suppose I can show you the assignment that I have given to you. There we have a questionnaire. Okay, I'm going to show you. Okay, here I have given you the questionnaire for practice. See, in survey questionnaire we have suppose demographic profile of the respondents. So we have the gender, male, female, ethnicity, Malay, Chinese, Indian, others, is years less than 20 years, 20. Okay, these are the demographic data that we put into the software, Spss software. If you go here, see. The case, suppose this the case means the ID, then the gender, suppose male and female, ethnicity, see the ethnicity here, Malay, Chinese, Indians, others, we have given here. If you check here, is years less than 20 years, 21 to 30 years. If we check here, is we have given the criteria less than 21 years and 21 to 30 years, 31 to 40 years, like this. So this is how we put the information to our in the variable. The criteria we put into the variable view, and based on that, this is the data that we put based on respondents' response. Okay, after collecting the questionnaire, that maybe this is called the questionnaire that we normally distribute among the respondents, and what the based on their response after collection of this field questionnaire, then we put the data into this software SPSS. So after putting the software, we then we do different kinds of analysis. Okay. Yesterday we initially, after putting the data, then we start we did the transformation, how to compute the variable. So suppose OC means organizational commitment. Suppose you have to write here organizational commitment, and you have to go to here, suppose statistical, and the mean, you will double click mean, and suppose this one comma, this one comma. Last day we have if you go through the video that I have given to you, you will be able to do it. So this is the data transformation. Sometimes we want the mean values. We have the 8 items for measuring the occupational commitment. So we want the organizational commitment. So this organizational commitment, we want the mean value. So when we calculate anything, suppose the correlation, regression, or the is a mean differences, then we need the mean value. So in that case, we need to transform our data. And how to transform it? You have to go to the compute, and you have to give the variable name, and you have to go to the statistical, and you can do the calculate it. So, and I have given you all the instructions here in your presentation slide. You will find there step by step. If you go through that, the compute, then statistical, then mean. Double click here, then it will go there. So then you give the ways and how to calculate it. It is to be like this, and that we need the descriptive statistics. So to understand our quality of our data in for getting our data set is what is the mean value, what is the median, what is the minimum, what is the maximum values. So for getting this, we need the descriptive statistics. In descriptive statistics, it is a summary of statistics that quantitatively describe or summarizes features of a collection of information, while descriptive statistics is the process of using and analyzing those statistics. So how to calculate this? And these statistics can be there are two types. One is frequency analysis. Frequency analysis we do for the demographic profile, and another mean, median, mode, or the standard deviation or standard error, or you can say the minimum and maximum. So all of these that we can do simply through the descriptive statistics in other way. So here in frequency analysis, you can present your result through the table and or by pie chart or bar chart or the histogram that you can present. That last day we learned it. How to do it? You have to open the file, Spss file, and go to the descriptive statistics and go to the frequency, and immediately you have to take which demographic profile you want to analyze. You just take it to the right side and go to the statistics, and if you need any bar chart or pie chart or histogram, that you can do. Then the result comes immediately. If you want the bar chart, you can do it. If you want to give it like percentage or frequency or count, you can. Last day I have shown you last day. So this is how we do the bar chart or pie chart or the frequency analysis that we have learned last day. And we have the numeric data. For the numeric data here, we need the mean value, minimum, maximum for the Likert scale data. The other data, so that we need, how can we get it? We have to go to analyze descriptive statistics, and you have to go to the descriptives, and you will learn. You have to take all the items to the right side and go to the option, and you have to select standard deviation, minimum, maximum, sum, variance, range, standard error, kurtosis, skewness. If you want to present the result of data normality also, all these results you can get. This is called descriptive results. Then continue, then okay, you will get it. So this is the mean value. This is the standard deviation. Minimum was 1. The respondent, they have selected the 1 as well and the 5 as well. So maximum 5 also selected and 1 also selected. So this is how we do the descriptive analysis, and we test the data normality. As yesterday I told you, there are two kinds of data normality. One is univariate and another is multivariate data normality. Univariate data normality, when we check the data normality for every observed variables, means every indicators for every items, then we say it is called univariate data normality, and that can be done through the skewness and kurtosis, and multivariate data normality, that test multivariate data, what is you have to calculate the mean value of the all the items for a particular variable, and that variables need to either you have to check that variables mean value of those variables, either it is normal or not normal. That can be examined through the Mardia test. So if we check the skewness and kurtosis according to Higher, the skewness and kurtosis value should be within the plus minus 2. The skewness should be within the plus minus 2, as the kurtosis values should be within the plus minus 2. And skewness value from plus minus 2, and the kurtosis also univariate. How to calculate the skewness and kurtosis? You have to go to the analyze and descriptive statistics and descriptives. Then you have to take items in the right side and mean, standard kurtosis and skewness. Then the result comes. And last day I have shown you how to present the result. Okay, this is the skewness value and this is the kurtosis value. Okay, Kolmogov and Shapiro test, we don't go through this now. The test of data, a test of outliers. Yesterday we have checked the test of outliers. As we know, there are two kinds of outliers. One is univariate outliers, and another is multivariate outliers. Univariate outliers is called if your data point that consists of an extreme value on one variable, if that is called the univariate data outliers, and that can be calculated through the Z-score. And multivariate outliers is a combination of unusual scores on at least two variables, two or more variables. Both types of okay, these outliers influence our statistical analysis, and the biased result comes. That's why we need to delete those observations who are outliers. So we have to delete it from our data set. And yesterday I have shown you how to calculate the Z-score for univariate outliers and multivariate outliers by Mahalanobis distance. As you know, if your sample size is more than 80, then it is if your sample size is more than 80, then it is called then your cutoff value, or the you can say rule of thumb for your value, the Z-score should be within the 3.29. If it is less than 80, it should be 2.25 within the range of plus minus 2.25. So if it is beyond that, then those observation are the outliers. Then you have to delete those outliers. Then in the case of multivariate outliers, that we can calculate through the Mahalanobis distance. So how to calculate the Mahalanobis distance? Yesterday we have learned. I'll show you. First we will check the univariate outliers. You have to go to the analyze, descriptive, then descriptive. Then you have to take all the items on the right side, and you have to select the standardized values as variables. Then your Z-score will be created. Z-score means standardized values. So these standardized values you have to go again to the descriptive statistics, and you have to go to the descriptive, and you have to take all these Z-score to the right side, and you have to go to the OK. Then the Z-score, the Z-score comes minimum, maximum, standard deviation and mean no required, only minimum and maximum we need. So this is called minimum number. It is minus 2.2. It is less than 3.29. As our number of observation is 477, so it should be less than 3.29, and it should be it should be higher than 3.29, and it should be less than 3.29, the maximum. So last day I have shown you how to present the Z-score result. Okay. Then univariate outliers, if the Z-score value beyond the plus 3.29 or minus 3.29 for a large sample size more than 80, then there is outliers. If the Z-score value beyond the value of plus 2.50 to minus 2.50 for the case of a small sample size, less than 80 samples, then there is outliers. So test of multivariate outliers. Now how to do it, I have shown you yesterday. A multivariate outliers is a combination of unusual scores that I told you. You have to go to the analyze, go to the regression, then go to the linear. Then you have to independent variable, you have to take the dependent variable here and independent variables, all the independent, we have the 4 independent variables here, we have taken here, and then we you have to go to the option save, and you have to select the Mahalanobis. Okay, we are calculating this through the Mahalanobis, and you have to select this, and it will be calculated. Then Mahalanobis, this result is coming, you have to short descending. Okay, so after short descending, you have to go to the transform for compute variables. Transfer compute variable, here you will compute a new variable, that is the probability. The probability result, how can we get this? You have to go to the functions here. If you select this one all, then you will find CDF chi-square. If you scroll down a little bit, then you will find that CDF chi-square. So what is the formula? 1 minus CDF chi-square in the bracket. In the bracket, you have to give this Mahalanobis distance. This one you have to take here, comma, your number of independent variables. In our case, our number of independent variables was 4. So we have given here 4. Then okay. Then the result, what the result comes, it's coming only 2 decimal. You have to make it 5 decimal. Then after that, the result comes. If this value, this probability value is higher than, sorry, less than 0.001, in that case, that is the outlier. So we have to delete those outliers. How to delete it? You have to go there and you have to click the right button and you have to delete that one. In our case, there was no outliers, so you can delete the outliers as well, no problem. So if the value of probability less than 0.001, then the observations will count as multivariate outliers. So today we will go through these tests. Everybody is ready now? If you have any questions in the case of yesterday, you can ask me. Otherwise, I will proceed for the today's session. Test of data reliability and exploratory factor analysis, one sample t-test, independent sample t-test, pair sample t-test, one-way ANOVA test, and two-way ANOVA test. If you have any questions, I am ready to give you answer. Otherwise, I can proceed for the today's practice. Okay, I can start. So first we will do the test of data reliability. Test of data reliability. What is reliability in data reliability? Anybody has any good answer, brothers? Hello, brothers. What is the data reliability, brother? Reliability. Okay. You have you know, the in social science, when we develop the instrument means the questionnaire. by which we collect the data. So we have the concept of data instrument validity and reliability. In the case of validity, this validity, suppose the contents, once we create the questionnaire, then this instrument or the questionnaire that we discuss with this questionnaire, we discuss with the academic expert, those in the field of that area, in that particular area from where you want to collect your data. Suppose you want to collect data from the marketing area, so you have to go to the marketing professor, those who has a very good knowledge about the marketing. So you can sit with him and you can show him that I have adopted and adapted this questionnaire. Please check it. Is there any ambiguity, or these questions are valid to represent these variables or not? Okay, so you have to consult with the academic expert. Then you have to consult with your industry expert. Suppose from the marketing department, from where, if it is consumer market and particular that market who are marketing that product, you can go to any manager of different companies and you can talk with them. This is the questionnaire we have developed for collecting the data. Is this valid or not? So you can you can check the validity from the industrial expert, from the academic expert, and from the language expert. Sometimes within the language there is some problems itself. So we need to check from the language expert. So is there any double barrel question or not, or the respondents can easily understand that question or not? So what kinds of language been used for collecting the data? So you have to check the language of the questionnaire by a language expert. Then you have to consult with the respondents. You have to give to them they are understanding your question or not. So this is called the validity. Before collecting the data, you need to during the pre-test, during your instrument development, you have to verify your instrument by the language expert, by the industrial expert, by the respondents, your prospective respondents, as well as your academic experts. And now, what is reliability? That is called the validity. What is reliability? Reliability means suppose for a particular in our case, organizational commitment, it has 8 items, right? So in organizational for measuring the organizational commitment, we have the 8 items. These 8 items are internally consistent. They are correlated, they are coordinated, they have a linkage among each other, they are interdependent. So we need to check it. Then if it is internally consistent, then we say it is reliable. So statistically, we measure it. After collecting the data, we check the reliability. Especially, we check the reliability during our pilot test. Before going for actual data collection, we collect a small scale of data. Suppose 30 respondents, or 40, or 50, or 12, 15, like this. We collect the data, and after collecting the data, we check the reliability, internal consistency, that we can calculate through the Cronbach alpha. If the Cronbach alpha value is 0.7 or more, it is acceptable. If it is less than, in between 0.6 to 0.7, then it is questionable. But if it is a small case of a small volume of sample, so it can be considered. You can go through this. Maybe when huge volume of data you will collect, maybe 0.6 is also acceptable. But 0.8 is good, and 0.9 and above is the excellent. So how we do the test of Cronbach alpha, or to check the internal consistency or the reliability. Everybody please go to your data set. The data I have given you, in your I have given you yesterday the same folder. Go to the same folder, workshop is okay, then SPSS workshop. So please, the 8 number file, 8 number SPSS file number 8, data set for reliability test. Just open this one. Okay, this one, everybody, you open this file, data set for reliability test. Are you ready, everybody? Hopefully everybody following me.
Okay, doctor.
Okay, thank you very
Go
much.
ahead.
I'm very happy that you are following me. Okay, how to do it? Go to analyze, everybody, go to analyze and go to scale and go to the reliability analysis. Just, and in the case of wedge, we have 1, 2, 3, 4, 5, 6 items per wedge. We want these items are reliable. Okay, so their internal consistency is okay as per our requirement. So you will take these items, all these 6 items of wedges, and you need to confirm that it is alpha. It is by default it is alpha, so you need not to do anything. Just click on OK. Then immediately you will get the result. Number of items is 6. Cronbach alpha is 0.935. So sometimes we don't know how to present the reliability analysis result. Sometimes students are very confused. So in that case, how to do it? I'm just going to open the yesterday's results so that I can share with this as well. Yesterday, I'm going to show you how to present the results of reliability. You will take this, you will create the table like this, like constructs, here you see it, yes, constructs. Then you will the number of items, then here the value of Cronbach alpha. Here is what is our construct? Construct is wedge, W-H-G-E, wedge. Number of items was 6, right? Here the number of item was 6 and the Cronbach alpha value is 0.935. This is 6 and alpha value 0.935. So this is how we present the result of Cronbach alpha, but all should be in together. All the construct value should be together. So the next, we shall go again to the next one. We have to go to the analyze and go to the scale again and reliability test. We will reset here, then it will go automatically in the left side. So we shall take the what is the case of welfare. In welfare we have 6 items. Sometimes we used to do a mistake when the students do not have any statistical knowledge, and even sometimes the supervisor also do not have adequate knowledge about the statistics. I have seen many students, they take all the items together like this, all the items together, and they create the Cronbach alpha value. But no, you cannot do like this. This is conceptually wrong and practically also wrong, because we do this due to under the same variable, what are the different items, these items are internally consistent or not. So the only the welfare, within the welfare, maybe if we do like that it is wrong. Why? Because it is comparing with ways and welfare. Ways and welfare is not the same thing. Ways is different variable, under ways is different variable, welfare also different variable. Yes, please. Okay, you will take.
Can you
Yes,
redefine the reliability, please?
reliability.
Yes,
Reliability
define
means
reliability.
okay. Reliability means the internal consistency of the items of a particular variable. Okay, they are
Okay,
internally
okay.
consistent.
Consistency.
Okay.
No, no. Yes, yes. Okay.
Okay, take these welfare items, 6 items, and click on OK, and it has, so welfare has 6 items and 0.931. How to present the result? So suppose welfare and 6 items and 0.931. So you do the rest of the one, you do the practice for another 4 minutes. Meantime, I shall complete my sola within 4 minutes. Okay, you do for the other, like satisfaction, performance, freeze, you do it by yourself, and I am coming back within 4 minutes after performing Maghrib sola.
الله أكبر الله أكبر الله أكبر الله أكبر أشهد أن لا إله إلا الله أشهد أن رسول الله صلى الله عليه وسلم الله أكبر الحمد لله رب العالمين الرحمن الرحيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد. سمع الله لمن حمده. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. قل أعوذ برب الناس ملك الناس إله الناس من شر الوسواس الناس الذي يوسوس في صدور الناس من الجنة والناس. الله أكبر. سمع الله لمن حمده. الله أكبر.
Assalamu alaikum. Sorry. Okay. Can you tell me? Hopefully you have done it. Just let me know what the result you got for satisfaction. Sister Nurul, how many items in satisfaction, and what is the result of Cronbach alpha? Tell me. Hello? Hello? Are you listening?
Yes, doctor. Yes,
Okay,
yes.
please tell me what is the number of items of satisfaction and what is the result of Cronbach alpha? Please tell me. I shall put here. You are not able to do it? Brothers, I told you to do the rest of the variables. Just tell me about satisfaction, performance, friends. Anybody? Please tell me. Then I can ensure that you
Doctor,
are
1
following
minute.
me.
I application this 1 minute.
I told you to do all of this.
Over satisfaction.
Doctor.
Yes, Sister Nurshida.
Number of item 12.
Shamna Shahida.
Okay.
Okay.
Okay. On satisfaction,
Satisfaction.
the
Yes. How
Cronbach
many
alpha
items?
value is
Okay.
0.931.
931. Okay. Then number of items, how many? 6 or 7?
The number of item is 6.
6, doctor.
Okay. Then tell me another. How about performance and friends? Performance. Yes. Yes. Tell me about the friends and the
7,
performance.
doctor.
Yes.
7 item.
Performance is 7 item, right?
Performance
Okay.
6, doctor. Performance 6 and
Okay.
friend 7.
Okay. How many? What is the Cronbach alpha value for the performance?
Just a minute.
That means you are not following. Brother Tanji Jin. How about you? Brother Tan Yang Hong. Brother Tanji. Okay, just tell me. Okay, yes, somebody already in chat there. Okay, sharing. Okay, mashallah. Nuraida Binte, yeah, she got very nice result. Alhamdulillah, where 6 item 0.935. Nuraida, thank you very much, sister. 6 and 913, performance 6 item 954, free 7 item 0.86868. Okay, mashallah. Okay, so just tell me the result. I want to put it here. Performance, brothers, tell me Cronbach alpha. Yes. Tell me, brother.
0.889, doctor.
889. Okay. How about the friends?
.894, Doctor.
0.894. Okay. So this is how we present the result of reliability. Okay, reliability results. Okay, if you go through this, how to do it? So variable by variable, you will be able to do it. Welfare. And what is the result? According to Uma Sakaran, less than 6 is poor, 6 to 7 is questionable, so 0.7 to 0.8 is acceptable, and 0.8 less than 0.9 is good, and 0.9 or above is excellent. Now the next is we will learn. Is it okay? The reliability test of reliability. Please check. Everybody, you have to be
Okay, doctor.
okay. I don't get it. Where is? Okay. So, are you following? Hello?
Yeah.
Yes, Doctor.
Okay, okay. This next one is exploratory factor analysis. So, do you have any idea what is exploratory factor analysis? Why it is required? Why it is required? And what is exploratory factor analysis? Okay, can you tell me what is exploratory factor analysis? Suppose when you develop the instrument, so it is one of the essential part for developing an instrument. Sometimes we don't develop the instrument by ourselves. Sometimes we take from existing literature. We adopt and adapt from somebody else's development. So that's why sometimes if we are exactly taking from as it is, then you need not require to do the exploratory factor analysis. But sometimes for a particular variable, some items we have taken from one author and some items from another author for the same variable. In that case, it is essential to do the exploratory factor analysis. What is exploratory factor analysis? The concept behind this, that suppose I have 7 or 8 items we have taken for measuring a particular variable. So these items, 6 or 7 items, are converging towards its own own variable, own construct, not it is loading with other construct. You understand? With adequate loading, and it is loaded with its own items. Suppose this is my hand, and these 5 items are setting with my hand. Okay, so others fingers will not set with my hand. So this is my hand, and my fingers will be set with my hands. The concept is this. So suppose you have 6 or 7 variables, and every variables you have maybe 2 or 4 or 5 items, and all these variables, all these items are loading with its own corresponding variables. That is the concept. It is not cross-loading with others. So let's go to, let's check what is the meaning of exploratory factor analysis? In multivariate statistics, why it is called multivariate? More than one variable we are using. That is called that is why it is called multivariate statistics. The exploratory factor analysis (EFA) is a statistical method used to uncover the underlying structure of a relative large set of variables. Large set of here the means observed variables, items, or the indicators, questions. EFA is a technique within factor analysis whose overarching goal is to identify the underlying relationships between measured variables. Suppose SPSS anxiety, okay, and this is the variable. This is called the latent variable or underlying construct, and these are the items. These items are loading with this. Okay. So there are some assumptions in exploratory factor analysis. Your data should be the Likert scale or Likert scale data or group data, and sample size, minimum sample size should be at least 4 or 5 times of a variable. Okay. What does it mean? Suppose you have you have 30 items. Suppose 5 variables, 30 items are there. So in that case, every variable has 6 items. So if you have the 30 items, these the minimum number of number of samples should be at least 150. Then you can do this exploratory factor analysis. Then the correlation matrix, it should be within more than plus 0.5 or minus 0.5 or less than plus minus 1. And QMO test, it should be at least 0.5. Then it will be significant. Bartlett's test, it should be in between, value should be smaller than 0.05 or that is the significant value. It should be less than 0.05. In the case of medical science, it should be less than 0.01. Eigenvalues, components or variables having value 1 and more than 1. Eigenvalue should be at least 1. I shall show you what is eigenvalue. So less than 1 cannot, you cannot consider the variables. Okay. Factor loading, if values exist in factor loading, it should be at least 0.5. And the multicollinearity requirement, we have the communality requirement. It should be at least 70 to 80%. So suppose you have a research framework like this, like wage, welfare, fringe, and job satisfaction, employee performance, like this. So how suppose in OAS you have 6 items, welfare you have 6 items, fringe benefit you have 7 items, job satisfaction has 5 items. Suppose employee performance has 6 items. So the items of employee performance, these 6 items cannot be loaded with the waste, cannot be loaded with the welfare facilities, cannot be loaded with the fringe benefits. So these 5 or 6 items, what is underlying items of employee performance, that should be loaded with this, and the items of job satisfaction which should be loaded with the job satisfaction. That is the concept of the EFA. So this is the, suppose satisfy, it has 7 items, and these 7 items under this satisfaction, and these OS 6 items would be loaded with these items. So this is the concept behind EFA. So how to do it? You will go through, go with me. Everybody please follow me. Go to the same folder that I gave to you. So 9 number we'll use open now data set for EFA, this one, number 9. Just open this one. Okay, we have this data set. So we have these variables like wage, welfare, satisfaction, performance, fringe. So all these variables under from human resource management. Okay, so these are the data we have collected. Now we shall do the EFA, exploratory factor analysis. How to do this test? We will go to the analyze. We shall open the file, data file, and we shall go to analyze. Everybody please follow me. This is a little bit complicated EFA, a little bit challenging as well. So go to analyze and go to the dimension reduction and then go to the factor. Okay, now we shall take all these items all together. And so we shall what is the requirement? We shall give the criteria over here. We shall select, please follow me, initial solution. Please ensure this, it is initial solution. Then coefficients, significance levels that we need, determinants we need, KMO and Bartlett's test of sphericity we need, inverse, then reproduced. We need to select all of this. Correlation matrix, we need all of these results. Then continue. Please follow me. Then continue. Now we shall go to the next extraction. What is the extraction that we required? Here we have different kinds of extraction, but we will do the principal components, this one. Principal components, and we need the script plot, and we need the correlation matrix, and based on the eigenvalue should be at least 1, and this. Okay, then click on continue. Then you just click on the rotation. Please follow me, everybody. Rotation. And go to the select the Varimax. We shall do the rotation is Varimax, in the way of Varimax, recommended the Varimax that we will follow, and rotated solution we will keep as it is, and 25 times iteration, so it is 25 times it will be rotated. Okay, then continue. Then scores. We need not to do anything from the scores. Then we shall go to the option. Okay, here we want exclude cases list-wise. We will keep as it is. Now we need to sort it by size and suppress a small coefficient. And here absolute value less the value below 0.50. We need at least 0.5 loading. So select this one and write here 0.50.
So just return to score, please.
Pardon? Pardon, sir?
Scores, Doctor.
scores 0.50.
Okay, doctor.
So after giving the criteria, then we shall click on OK. Then different results is coming. We have to extract only 5 results. This is the correlation results given correlation matrix. We need not to have this one. Inverse of correlation matrix. We need not to have this one, but we need this results. KMO and Bartlett sphericity test result. This Kaiser-Meyer Walkin measure of sampling adequacy. This should be here it is 0.889. It should be at least 0.5. This result. Okay, this is the requirement. And the significant value Bartlett test of sphericity. This significant p-value should be less than 0.05. It is 0.000, which is less than 0.05. So we shall take this one and we shall put this result, but not now. When all the values are okay, then we shall take the final result. Now this is called communality. This is the loading extraction. The Waze one, it is loading with 0.704. Waze 2, it is loading with 0.722, like this. You have to check is there any values less than 0.5 or not. Yes, we have one value less than 0.5. That means this may create the problem. This value, it is not sufficiently loading, so it is below 0.5, but we will not we will keep it as it is now. We will just observe the result, principal component analysis. Now we shall go here, total variance explained, this one. So here we will check how many eigenvalues. Here if we check only 5 eigenvalues having having 1, at least 1, that means we have the 5 variables, 1 2 3 4 5 variables as the 1. Then after 5 it becomes, that means you have the 5 variables and with its recommended items. And we have to here a percentage of variance. When we observe, see this variable is higher than this variable is higher than. After 5, if we check if we check here, after 5 it is less than 1. Understand? So, and we have to check the communality. Here communality is 73%. It should be at least 60%. The communality here 73.987. So it is above the 60. So it is okay. And after 5, because we have the 5 variables, ways, welfare, fringe, satisfaction, and performance. So 5 variables having more than one eigenvalue. So it is total variance extracted. You have to check this result. Now we shall check this one, scree plot. This scree plot, suppose this one 1 2 3 4 5. It must be in elbow like structure, and there should be number of, you have to check how many variable this or every this point is called every variable. So we have the 5 variables, and here you see in the elbow 5 variables are there. Okay, that means it is almost okay. Now rotated component matrix, we need not to have like this one. We have to check this one, rotated component matrix, this one. Here if we check the performance, all these are under this one column, but here you see the fringe 7, it is cross loading. with this performance. It is not supposed to be here, but it comes with the performance. So it is a problematic items. It has a problem. These items not fitting with this here. These items fringe 7 should be it is supposed to be in fringe 7 would be here in column number 5, this here, but it is loading with this column number 1. So we have to delete this. All other items like ways 1 2 3 4 4, all the items are loaded in the second column. Welfare loaded, all the items of welfare, it is loaded in the third column, and satisfaction items are loaded in the fourth column. But in fringe benefit, this is the most important results that need to be present in the EFA. So this fringe, except the fringe 7, all the items loaded with the seventh column. Now what we have to do, we have to go back to other, since we have the problem in fringe 7. Now we will exclude these items when we will run the analysis again. We have to go to the analyze, and we will go to the dimension reduction again. Go to the factor, and from here we have the different items, right? Here, from here, this problematic fringe 7 we will exclude from our analysis because it is problematic. You will take to the left side. It is in, you just select this one and click on here, and it will go to the left side, and we will analyze again. All the settings remain the same. See, all the, it is no need to change anything. You will just click on OK. Everybody, please click on OK. Okay, this correlation matrix, we need not to have this result, inverse correlation matrix. And now see, it is improved. Okay, Kaiser Meyer working test express, it is more than 0.5, and significance is less than 0.05, and loading, none of the loading is below 0.5 from the communalities, all are okay. Now we see all of the result here, it increased. Earlier it was 0.73, sorry 73, now it is 75, and 5 variables are more than 1 eigenvalue. So, and script plot, it is 5 items, 5 variables. It is in elbow shaped in hands, and we shall go to the rotated component matrix. So this is the now the result is very fine. 6 iteration, and see, this is the result. All are loaded in different columns. So how to present the results? So first of all, we shall collect the result of KMO. This one, how to present this result? We will copy, click the right button and copy, and go to your Excel sheet. And how to present the result? You will just Control V. You have to, how to present the results. Sometimes it is very important to know. Okay, this is the KMO. I'm showing you. In your case, you will do your analysis result presentation this way. So now you have to beautify and decorate your results. So this is how we present the result of KMO Bartlett. Okay, you can, in this case, you can use this one as well. Then it will look like fine. Okay, this is the result of KMO. Now you will go to the result output view again and go to the communalities. This communalities result we present in our thesis. This communalities result extraction here. Okay, so go there, center, number, okay, and we shall go there. Okay, this is the standard of using items. This is the extraction, the communalities. Okay, now we present the result of total variance explained, the eigenvalues result. How to present this result? We will not present the whole table. We will present the result of this. I'm going to show you. Sometimes students cannot understand. They can do the analysis, but how to present the results, they don't understand. So we will not keep all the results, all the table. We just going to show you after this one. All the results are less than 1. So after two row, we don't present. Okay, we delete all of this. So how to present this? This is a standard format. Okay. Now I shall present the results like this. So after today's session, I shall send you some thesis and how to explain these results in the thesis or in the article. You will learn it. Okay, all the SPSS thesis I shall send you. No problem, inshallah. So eigenvalues, this one is extraction of loading, and this is, so this is how we present. Okay, you can be like this. So this is how we present the result of total variance explained. Now we shall extract the result of script plot. You just copy and paste there, nothing, as it is. But when you will present these results in the okay, I'm going to open the figure results. Sorry, Uniten. Okay, table in Word file. So how do we present the result like this? You will present, and you will go to the here picture format. You will go to the picture format and picture here. You will select this one. So this is the script plot by which you can present nicely to your thesis. Now we shall rotated component matrix that we will present in fifth result that we used to present the result, and we take it to the Excel sheet. And how to present nicely this one? Okay, this is the items, and here, okay, similar way as I shown you before. So it is better, but here in this case, what will you do? You will do in this case, you will do like this. You can give a shadow. Okay, so it will be look like very nice. This way you can present the result of rotated component matrix. Okay, this is how we do the analysis, EFA. And every steps that in your this is your lifetime slide. If you forget, even if you have this slide, if you follow the slide, you can easily do your analysis. And if you have this video, inshallah, maybe the organizer, they will distribute this video, inshallah. If you follow this one, then you will not have any issue for doing this EFA analysis. Now, another very important analysis for SPSS is the testing of means. Means the average. Then there are different tests that we can do. Suppose that we will assume in here simple, different test we can do through the mean value. How to do testing of means? Testing of means is, this analysis illustrates that whether there is a difference between two groups or among three groups, and it is significant. Okay, when you have different groups of results and or data, and after so when we comparing between the two groups or more than two groups, so sometimes we make an assumption these two groups are there is no significant difference in null hypothesis, and in alternative hypothesis we assume that there is a significant difference between these groups, and different kinds of study that we can do through this means study, and different kinds of testers available for this means analysis. Two assumptions here: if data does not come from a normal distribution, or sample size is small, meaning that less than 30, then non-parametric test. If your sample size is less than 30 and your data is not normally distributed, then you have to go for the non-parametric test. We have another set of tests that is non-parametric, that is if your data not normal and your sample size is less than 30. If data comes from large and normal distribution, then we do the parametric test. If it is non-parametric, we do these kinds of tests here. If we have the parametric data, then we can do this test: one sample t-test, two sample t-test, here independent sample t-test, and more than two sample t-test, that is called ANOVA. If it is one sample and within two sample, it is t-test. When we go more than 2, then the ANOVA starts. One-way ANOVA, two-way ANOVA, one-way repetitive measure ANOVA, mixed factorial ANOVA test. Different ANOVA tests are there. So we shall learn today how to do the t-test, one sample t-test, two sample t-test, independent sample t-test, pair sample t-test, and more than, and what is how to do the ANOVA test. So if you have one sample t-test, what is that one sample t-test? Please follow this one. The one sample t-test compares a sample mean to a hypothesized population mean to determine whether the two means are significantly different. One group, we have the assumption that is the hypothesized mean, that is the mean. We hypothesize that the mean value may be this, and what is the actual one? We compare the hypothesized mean with the actual mean. So if the difference is significant, then we make the assumption. Okay. One sample t-test determines whether the sample means is statistically different from a known or hypothesized population mean. The one sample t-test is a parametric test. So we have the test is also known as single sample t-test, and the variable used in this test is known as test variable. Don't be afraid, I shall give you the example. If one sample t-test, in a one sample t-test, the test variable is compared against the test value. Test value is hypothesized value, test value, which is known as hypothesized value of the mean in the population. So in one sample t-test determines whether the sample mean is statistically different from a known or hypothesized population mean. Our statistical analysis show what the mean value we are getting. This is a difference from the hypothesized population mean. So we have the sample data must comply 3 conditions. Number 1, it should be scale data, it should be normally distributed data, only one sample data, one sample would be there. So let's null hypothesis. We assume that hypothesized population mean is 3 in our example. I shall show you in our, we have a data set there in the score. We are assuming that the population mean is 3. That is the assumption. In null hypothesis, it is telling that the sample mean is not significantly different from the hypothesized population mean. In alternative hypothesis, it is telling that the sample mean is significantly different from the hypothesized population mean. If the p-value or significant value is less than 0.05, then we reject the null hypothesis. Why it is less than 0.05? If we want 95% confidence interval, 95% accuracy of our study findings. So that's why it should be less than 0.05 or equal to 0.05. Then the null, we reject the null hypothesis, means we accept the alternate hypothesis. That is, the sample mean is significantly different from the hypothesized population mean. Let's see the example. We have the GPA score of 15 students. The GPA score of 15 students here 3.50, 3.90, 4.35. You see this sample GPA score, we are thinking that our sample mean, maybe we are assuming the mean score is 3. So now we shall calculate the actual mean. So then we will make the difference between this sample mean and our assumption is 3. Is this the difference is significant or not? That we will observe. So everybody please go to the analyze, and you will go to the compare means, and you will select one sample t-test. Then you will take grade point average GPA. Then here we will give the test value 3. Our hypothesized mean value is 3. Then we'll go to the options, and we will ensure that it is 95%. It is by default 95%, but we need to check it.
This any file, Doctor, this.
I shall show you which file we shall do. We will do the practice now. Okay, everybody please go to the folder I have given to you. Workshop on SPSS, Unit 10. Here, one sample, number 10, one sample t-test data. T-test data set. One sample t-test data, 10, number 10. This is the GPA score, brothers and sisters. This is the GPA score. We will here we are assuming that the mean score, average mean score is 3. But is it really 3 or not? We will analyze it. Go to analyze, everybody please go to analyze, and the fourth option is compare means. And if you go to the right, you will find one sample t-test. Please everybody go to the analyze, compare means, and go to the one sample t-test and click on there. You will find a window, and this grade point average is there. So you will take it to the right side by this one here in the middle, and test value is our 3. Here put here 3, everybody please. Test value, our hypothesized value is 3, and go to the options and ensure that it is 95%. Anybody can explain what is the 95% means? For brainstorming, anybody can explain? What does 95% confidence interval percentage is 95%? What does it mean? Anybody can explain? Please, I want an active participation from you. I know you are very talented. What is 95% means? Confidence interval 95%. I just explained to you. Can anybody explain? Please.
It was a significant level to reject the null hypothesis.
MashaAllah. Who is
Reject.
this? Nuraida or
Reject.
who? Who
Shahira,
this?
doctor.
Huh?
Shahira, doctor.
Saira, thank you very much, my dear sister. For
Okay,
confidence interval, 95% accuracy of our study. Just continue. Then OK. Here, just click on OK. The result comes. Here, if we check one sample T statistics, one sample test statistics, grade point average, total number of observation is 15. Mean value, actual mean value, it comes 3.76. This is the standard deviation, this is the standard error, okay. So we shall check here the difference, mean difference is 0.76. Our assumption was the mean value would be the 3, but it is more than 3. It is 0.76 is more. The mean difference is 0.76. Now this 0.76 is really significant difference or not. How can we ensure it? We shall ensure the significant here, significant to tail here. The value of this is 0.000. That means which is less than 0.05. Right? So now we can assume that it is significant, but we can our assumption, the result also confirm from this lower level, lower bound and upper bound. 95% confidence interval of the difference. If lower bound and upper bound both are positive or both are negative values, then we can confirm it is significant. Now we have the another values, that is the t values. If the t value is more than 1.96, then it is significant. There is significant difference. So these t values should be more than 1.96, and this 95% confidence interval of the difference would be either upper, lower and upper, both should be either positive or negative, and this significant level to tail should be either should be less than 0.05. Okay, then it is significant. So our result is significant. So how can we explain this? So this is the decision criteria. Since the significant value less than 0.055, which means we reject the null hypothesis. It indicates that sample mean is significantly different from the hypothesized population mean, that was 3. You understand? So this is the decision criteria. This is the decision. Now one thing I shall ask you, what is the two-tail means? Can anybody can explain? What is the two-tail means? Sometimes in social science research and statistical analysis, you will find even in structural equation modeling, you will also find two-tail or one-tail, two-tail or one-tail. What does two-tail and one-tail means? Suppose if in our, anybody have any idea about this? Please speak. I want your active participation. Brother Rayed Kurdi, can you? Brother Rayed? Sister Laila, are you there? This is very important question. Are you there? Everybody there? Hello?
Yes, sir.
Hello.
We are
Yes,
here with
yes.
you.
We are here with you.
Okay, it's very important question. What is the two-tail and one-tail? What does it mean? You have any idea about this? Okay, I'm giving you the theoretical concept behind this. We develop in our quantitative study. That means actually normally we have either quantitative research or qualitative research. In the quantitative research, or if you are following the positivist research paradigm and explanatory research design, there we take a theory. Based on theory, we develop a certain hypothesis. Okay, in the hypothesis, we sometimes we hypothesize like this: there is a positive relationship, there is a positive effect, there is a positive impact. When we hypothesize like this, then it is called one tail. Okay, in one directional, if it is one directional, either it is positive, or sometimes suppose we say discrimination has a negative impact on employee performance. Okay, so if you are hypothesizing your assumption like this, then it is unidirectional. Then we use the one tail. If we are just telling that there is a significant organizational politics has a significant effect on employee performance. Sometimes the result comes organizational politics, sometimes the result comes positive relationship, sometimes it comes in the negative relationship. So if it is like, if we are accepting both the result, either positive or negative, then it is called two tail. In two directional, a result may come and we are ready to accept it. So it is called two directional, and then we use the two tail. And one tail, if we are strictly one directional, positive significant effect or negative significant effect, we are strict on this, then it is called one tail in unidirectional. Okay, you understand the concept? So in our case, it is we are ready. If the mean value, if it comes the negative values, we were ready. If the mean value is less than 3, maybe 2.25, if it comes, then it comes the negative value. Then the lower and upper, if it is significant, the both would be the negative values. So it is it might be also significant, the negatively significant, like that. So this is called the one tail t-test. The decision is, since the significant value less than 0.05, which means we reject the null hypothesis, it indicates that sample mean is significantly different from the hypothesized population mean. Next test is independent sample t-test. What is independent sample t-test? The independent samples t-test compares the means of two independent variables in order to determine whether there is statistical evidence that the associated population means are significantly different. The independent samples t-test is a parametric test. So how to do it? Suppose in independent sample t-test, in our example, we have the male and female GPA score. Suppose the GPA score of based on the gender, we have the 15 male students, their GPA, this, and we have the female students GPA. So in null hypothesis, it is telling that there is no significant difference between male and female towards GPA score. In alternative hypothesis, telling us that there is a significant difference between male and female towards GPA score. So we shall, this was our assumption, and we have developed two alternative, one null hypothesis, one alternative hypothesis, and let's check as our prepared sample, how can we do it? You will go to analyze, compare means, and independent sample t-test. Just everybody please follow me. You will go to the file number 11, go to the same folder and open this independent sample t-test data. Please open this one, independent sample t-test data. So these are the data, 30 data, 15 for male GPA score and 15 for female GPA score. So just a minute, Sister Laila, given me the code. Yes. Okay. After this, we will have another one, that is the one-way ANOVA. Then we will pair sample and ANOVA. Within 10 or 15 minutes, we can finish. So what can we do now? Go to the analyze. Everybody just open independent sample t-test data. Go to the analyze and go to the compare means. Everybody go to the analyze, compare means, and go to the independent sample t-test. Click on there. You will find a new window there, and you will take this is the GPA score, is our test variable. GPA score, you will take GPA score in as a test variable, and group, the gender group, you will take as grouping variable here. Now after taking this, everybody please follow me. You will take the test variable GPA score here, and grouping variable is our gender. When we take it, it is activated by define groups. How can we define group? Just click on there and you will define the group. One is here, you will give one is our male and two is our female. Everybody please follow this. And just click on continue. Then option 95%, it is by default given. Then okay. Now the results comes. Now the result comes like this. Male is 15, number of observation 15, female also 15. Mean value of the scores is 85.20 for the male and female 76.05. So is there any significant difference? So let's check here. In the equal variance assumed here, you will check here. This is the significant p-value. It is less than 0.05. It is 0.011. This is less than 0.05. So we can, and mean difference was 9.133, which is significant. Here we will see the significant, and lower bound and upper bound both are positive. So positively significant. So this is how we get and we present the result. If you go here and how to present the result, if you follow my instruction on the slide given, you will find these results you have to present. Okay. Now since the significant value of p is less than 0.05, which is 0.011, it indicates that null hypothesis is rejected, which referencing that there is a significant difference between male and female for obtaining GPA score. The male students are better than the female students. They obtained more GPA score than the female. That is the significant difference. Okay. Now we have another test, pair sample t-test. What is pair sample t-test? Spss's pair sample t-test is a procedure for testing whether the means of two metric variables are equal in same population. Both variables have been measured on the same cases. Although pair samples suggest that multiple samples are involved, there is really only one sample and two variables. One sample means we have the same participant. We take the test for pre-test before training and after training, post-test. This is we rename as pre-test and post-test. Is the test score they obtained for our training program was really made some improvement among the students or not. That's why in the beginning the students taken a test, the SP test, and after training take a test that is called post-test score. So we have the pre-test score and we have the post-test score. Now, is there any significant difference between the pre-test score and the post-test score? That we will do. How can we do this? In null hypothesis, it is telling that there is no significant difference between pre-test score and post-test score. Alternative hypothesis is telling us that there is a significant difference between pre-test score and post-test score. So how can we do? After importing your data set, providing names to the variable, go to analyze, compare means, pair sample t-test. And how to do it? You will go to analyze, compare means and pair sample t-test. You will select this one. And you will take this one, score test, p-test here and post-test in variable 2. Then option 95%, continue, then what the result comes, we will observe the result. Everybody please open the another file, pair sample t-test t-test data. Pair sample t-test data. Just open this one, pair sample t-test data. We have the participant, 10 participants, pre-test and post-test. Now everybody please follow me. Go to the analyze, then compare means and go to the pair sample t-test, this one, and click on there. So we shall take this one. If we click on here, select this one and go here, and this one, select this one and click on here. You got the point? Suppose reset, you select this one and click on here, and select this one and click on here. It will go variable 1 pre-test score and variable 2 post-test score, and option 95%. It is not required, it is by default 90. Then okay, it is very simple. Then the result comes. The mean value of the pre-test is 71.30 and post-test after training 89.40. So the difference is minus 18.10. So this 18.10 is a significant difference or not. So we will check here the pair sample difference here. We will check this one. This is the p-value. P-value is 0.000. Okay, it is the 100% confidence interval. There is a significant difference. This is the p-value is more than 1.9. It is 7.830, and lower and upper bound both are negative. So it is significant. And 95% confidence interval, it is both are negative. That's why 0 not in between. That confirms that there is significant differences. So how to since the significant value p-value is less than 0.05, which is 0.000, that means a null hypothesis is rejected and alternate hypothesis is accepted. It indicates that there is a significant difference of training scores between pre-test and post-test. Okay, this is the results. This is the result. So we have today we will do one more analysis, that is the one-way ANOVA. We have a pre-test and post-test, pair sample t-test. Now we will say if you have more than 3 variable, the one-way analysis of ANOVA is used to determine whether there are any statistically significant differences between the means of 3 or more independent unrelated groups. Okay, so example of one-way ANOVA. Suppose there are 3 teaching methods. One is traditional, another is machine learning, and we have another one that is blended, traditional plus machine learning method. Okay, so the scores of day obtained by students under these three teaching method, now one way ANOVA is used to determine whether there are any statistical significant differences among the scores obtained by these three methods. One is traditional methods. The students obtain the result, test score is this, sorry. And second was the machine learning method, and the test score, they obtain these results. And the blended, that is traditional plus the machine learning method we use there, and the students obtain these results. So we shall compare the mean of traditional method and with the machine learning method with the blended method, combined of these two methods. So is there any significant difference or not? So we shall go to the analyze, then compare. We will go to the compare means, and you will select the one way ANOVA. Okay, then you will take that score test score there in the right side, and the teaching methods will take as factor. Okay, then we will select in post hoc multiple regression. We will click on there, post hoc. Here we will select the key, the Turkey. We will select the Turkey, then click on continue. Significance level is 0.05, then continue, then okay, then the result will come. So let's everybody go to the last analysis, that is the 14 number one way ANOVA. Please click on one way ANOVA, and if you you got the three teaching method, number 1, 2 and 3, and these three scores are there. Now we shall go to the analyze and compare means, and click on one way ANOVA. Everybody please follow me. Go to compare means and one way ANOVA. So teaching method will go here, teaching method will go in factors, and scores of test will go to the dependent list. Please follow me and go to the post hoc. You will select here Turkey. Different kinds of tests are there, but the Turkey is the best, and it is by default it is 0.05, significant level 0.5. Turkey is the best. It gives the significant level, but other Dunkin and others do not give the results like the results of Turkey. They don't give the result like Turkey. So that's why we will follow the Turkey. Then continue. Then okay. The results comes. See some of the scores. Here, traditional versus, if we see the result of Turkey, traditional versus machine learning, the difference is minus 0.40. Minus 0.40, it is not significant because the significant level is more than 0.05. That means we accept the null hypothesis. So traditional versus machine learning method, we do not have any. Yeah, and even you can confirm it. See, the lower bound is negative and upper bound is positive. That means there is no significant difference. Okay, machine learning versus traditional method, and traditional versus both traditional and machine learning blended. This is also not significant. This is lower bound is negative, upper bound is positive, and significant value is more than 0.50. And here and the difference was 3.60. If we compare the machine learning method with the traditional method, it is 4.0, but it is also not significant. And this one, both traditional and machine learning method, both altogether, it is not significant. And both the blended learning with traditional method, it is not also significant. Here, it is not also significant. So we can calculate that, we can come to the conclusion that the significant value between groups is higher than 0.05, that indicates to accept null hypothesis. Similarly, pairwise results also showed insignificant. So this was the session for today. So hopefully our time is up. Now, Sister Laila, if you have any questions, you can ask me, please. And any questions regarding the regarding your thesis, your research, or anything, I shall entertain, or any kinds of questions regarding your research, your conceptual framework, your gap, your problem statement, or regarding any kinds of analysis. You can ask me. This is your privilege. I am with you. You know, sometimes I conduct a different workshop like A to Z research solution, and I have another workshop in 2nd April. It is the research design, then research design, role of theory in research, and mediating and moderating variables, and conceptual and theoretical framework. So these are the different workshop that I conduct. I have the AMOS workshop, Spss, Smart PLS workshop. So you can ask me any question regarding your research. I am with you, brother.
Doctor, but I ask you for the thesis. Tell me
No problem.
share with our please.
Okay. By tonight, inshallah, I shall send to Sister Laila. She will distribute among you, inshallah. No problem. I shall give some thesis on SPSS. And if you want is based on Smart PLS or AMOS, that I shall give some. 3 from SPSS, 3 from Smart PLS, 3 from AMOS, I shall give you, no problem. Very good thesis, I shall send you, no problem. If you have any questions, please ask me.
Assalamu alaikum.
Wa alaikum assalam.
Uti Muhammad Busaidi. I'm from Sultanate of Oman.
Okay.
And I'm a PhD researcher.
Are you in Oman now?
Yep. Now I am in Oman. The time is now in Oman is 6 and 10 minutes, like that.
Okay.
PM.
Okay.
Yeah, alhamdulillah. Doctor, just I have a small question about the systematic analysis. What's the difference between PLS and SPSS?
Okay. What is the difference between PLS and SPSS? Okay, very nice question, brother.
Okay.
Actually, please.
Sorry. Because I will give you the reason. Because my supervisor, he told me, Muhammad, you have more variables, which is affect the DV, which is DV, under of the DV. There are a lot of variables, around 6 variables, which is under of DV, which is the dependent variable. And he just explained me about just this in this area. And he told me in the polite way, Muhammad, I am not that person which can explain you and teach you about which is PLS.
Smart PLS.
And that's one of the reasons what he told me. And still, I am not getting the main idea. And now I hope to listen from you. Thanks.
Okay. Maybe coming month on April or May, I'm coming in Oman. Al Jahra women college there. They are inviting me to go there and conduct step-by-step thesis writing, research design, AMOS, Smart PLS, and SPSS. I am in the process for visiting there in Oman for maybe for 15 days. So, however, brother Busaidi, in SPSS, it is the first generation data analysis tool. It is we were using it since 50 years or 60 years. SPSS. It has many versions, and we are using this one. But we can do many analysis by SPSS, but we cannot create the framework. We cannot create the model by using the SPSS. We can do the only analysis, we get the result. But in suppose we have the regression analysis, we can do the correlation analysis for getting the effect or impact, the effect of IVs on DV, and mediating moderating also, that we can calculate through the SPSS. But we cannot create the structural model. So this based on your suppose in your theoretical framework that your whole result that you want in a with a graphical representation, either you got what the results you get, that you cannot do it in SPSS. So the next generation data analysis tool like SPSS, AMOS, then RAP PLS. So these are the results. You can graphically present your results. So you have the some additional features over there by which you can create the model. So you can present the results based on your graphical representation. Okay. Here some additional additional results also
Muhammad.
here. Yeah, please.
Yes, thank you so much, Dr. Muhammad, for enlightening us today. Guys, if you have any question, just you can ask. For me, I have two questions, doctor, as a student.
Okay, please.
As a PhD
Please.
student, right? If I understand you, doctor, regarding the mediating and moderating and control variables, it's not including here in your session.
No. No, that mediating and moderating variable that would be included in Smart PLS and AMOS, not here.
Okay. And the second question is, doctor, all the what we call that one? All the t-tests that you
Yes.
have explained today, and all the tests, not only the t-test. It depends on the simple size, doctor. It means all the tests that you have explained today will not all considered. It depends on our, let's see, for example, I have, for example, 300 SMEs, okay, and I have around 11 IV and 1 DV. Here, which test I have to consider if and all this, the things that you already explained it before, doctor.
Okay. Okay. When we have the hypothesis like if you have the model like we have several IVs, what is their effect on the DV? So tomorrow I shall explain it in. We can do it in regression analysis. Tomorrow it is in advanced level. Tomorrow we shall I shall explain in the last stage. In regression analysis we have simple linear regression and multiple linear regression, by which you can calculate your result.
I think you didn't get
study.
my points, doctor. Yeah.
Maybe. Okay. Please, can you?
Yeah.
Can you explain?
My question. Yeah. My question is, all what you have explained today about all the tests that we had today, Or we should apply it in our research, or it depends on our sample size?
It is not depend on sample size. It depends on your research objectives and what kinds of data you have. Actually, if you are intended to compare the means, then you have to go to the t-test or ANOVA test. If you are going for observing the impact or the effect of different variables, so in that case you have to go for correlation analysis or regression analysis. So it depends on how you design your research. It depends on your research objective system.
Doctor, let's see, let's take an example about outlier. Outlier, it should be the sample size less than 80, right?
Actually, it is not outliers less than 80 or more than 80. Actually, what happened, as soon as we collect our data from the respondents, we put all the data, we give input to the SPSS. Once we give the data input, now we check our data quality. We check is there any missing values or not, is there what kinds of data it is, parametric or normally distributed data or non-parametric data. Then we check is there any outliers in our data set or not. So in that case we check two kinds of outliers. We univariate outliers, multivariate outliers. If the outliers is there, then we delete it. Then we make these are the perfect data set. So we don't have any outliers in our data set. Now it is ready for the analysis.
Yeah, thank you for your clarification, doctor. Thank you. Is there any question, guys, here? Otherwise, we'll proceed to the photography session, please. If you don't have any question. No question? Okay, now we'll proceed with the photography session. Please open your cameras.
Assalamu alaikum.
Wa alaikum salam.
Hello. Thank you again, Dr. Muhammad, for today's sessions. I believe that it was beneficial to everyone here. I should have to recall people now to turn on their cameras, please, so that we can take a picture all together. Could you please turn on your camera? All right. I need more people. Thank you for those who are turning on. Thank you so much. May I have more, please? All right. So on count on three. So I'd like to count on three. 3, 2, 1. Could we have please freestyle? Freestyle, please. 1. Someone is shining here, Omar bin Sawad. Thank you so much. All right, 3, 2, 1. One more, please. 3, 2, 1. Thank you so much, guys, for your commitment and turning on the camera. You're looking good, mashallah. Your pictures, inshallah, will be posted on our ISIS social media. Thank you. You can proceed, Dr. Leila.
Yeah, thank you so much, Hudhaifa. Now, kindly, I want all of you to prepare your phone to scan the QR code to get your score on. The QR code will be shared for a specific time, exactly 5 minutes. And for those are not able to scan, you can find the link in the chat section. If any of you facing any trouble with scanning, please let us know so we can help. The 5 minutes start from now.